Welcome everyone to this webinar, how we could combine Automotive SPICE and the Scaled Agile Framework. The agenda we prepared would look like this: small introduction, so why am I here talking about these things? Then a quick recap about Automotive SPICE and SAFe, and then how we bring it together. So the first topic point here would be more on a high level. So where would we have to go into details, and where do we see no problems at all? And then we have a small section with a deep dive on some of these topics, and at the end we will have time for questions and answers as Renee announced. So why I'm here? So since 12 years in the meantime, I worked with agile approaches in the development of physical products, did a lot of things like camshafts, fuel cell systems, control units, train compressors, semiconductors, whatever. So wrote several books about agile systems engineering or agile product development. I'm an SPC in SAFe, so provide some trainings and also a provisional assessor on Automotive SPICE. And we talk currently about the process assessment model version 4.0, which has been released at the end of the last year. So I think, or I hope that every one of you in the call is quite aware of what Automotive SPICE is. Just a quick recap. So the goal of all this SPICE things is to improve processes in software development and systems development. And it started off in the 1990s, where the automotive industry ran in some troubles, where a large transformation was there. That the companies had to transform from like electromechanical companies to software companies, and the first approach was the CMMI to measure or to assess process maturity in product development, and later on the industry agreed on Automotive SPICE, so also the results of the assessment could be transferred between the OEMs. And the suppliers don't have spent their whole time as doing assessment from different customers. And Automotive SPICE is derived from an ISO standard 15504. Now it's transformed to the 33000 series. And as we will see, those standards provide how we do the measurement of process maturity. For each industry, we have to define our own assessment model. So there's a SPICE, for example, for space. So the European Space Agency has a space SPICE, or don't know how it's called. And so they have been developed different assessment models for different industries, and Automotive SPICE is the assessment model for the automotive industry. Those of you who are familiar with the process assessment model or the standards would recognize this chart. So we have the measurement framework. This is provided by the standard. And the automotive industry then developed a process reference model, which contains what processes are there and what are should be the outcomes of the processes. And the second thing is the PAM, the process assessment model. This is how will we do assessments on the process and get this grade. And here you have these capability levels for each process, maybe a different level like 0, 1, or 2, or for some the goal would be even 3. And we could discuss if the jump from 2 to 3 will increase quality further, or it is just a huge effort without any results. So these are discussions going on in the industry. But once again, so we have the standard for the measurement, and we have those documents. They are combined now in this document I have shown in my introduction slide in the version 4.0 now. What's important, not companies are rated, projects are assessed. So there's not a company with a certain SPICE level. So the standard is the capability level, but normally we talk about SPICE levels. And not the whole project is rated with a level. It's process by process. So the result of one project assessment would look like this. We have different capabilities levels. We could have different capabilities levels for each process in the assessment. And when we turn towards the direction of how could we combine this with agile approaches like SAFe, we have to talk about the good old V model. So I hope everyone in the call knows the V model with the two directions of traceability. And what's very important, the V model is not a process, it's just a concept of how artifacts and activities relate to each other. So it shows us dependencies between activities and artifacts. It doesn't provide any timeline. So we could, in an extreme case, to change everything at the same time, and then we would have to care about consistency in all this documentation with all these links. And what many companies did, so the first thing is people talk about the V model, so we don't have the V model. The V model is another standard used for IT projects for the German government. What we use in the engineering are normally V-shaped models, and everything I do is a V, so we can't develop anything without using a V, even if it's an implicit V. For example, if I cook a spaghetti, it's also a V model. I have some ideas what I want, and then I do a decomposition into pasta and sauce, and then I will produce it, and then I will integrate it and do some integration tests in my pan. And at the end, I will check if the pasta fulfills all my requirements I had this afternoon. And so everything we do in development follows this approach, and we could have several layers. So SPICE talks about a system and a software layer or mechanical layer here. But in the end, it's all the same pattern. We have on the left side decomposition and definition. We have the build and on the tip, and on the right hand, we have integration and verification. And what happened in a lot of companies that when they had to define a process how to develop, they just took this poor V and squeezed it down to a flat V, and then the sequence would be from left to right, from system requirements elicitation or analysis back down to here the system test. So we stretched this poor V. And then we called this PDP, or Produktentstehungsprozess, or product development process, by introducing some funny gates like the requirements freeze, design freeze, and so on. You all know this. And so sorry, wrong direction. So we introduced a lot of freezes. And the point why we talk about SAFe today is we introduced also a lot of wishful thinking. So they are started from the 1990s, from Harley-Davidson, for example, and they have shown with historical data that the better the projects run through these freezes, the higher was the risk at the end of the project. And from lean development side, this is called wishful thinking because from the lean point of view, we can't freeze a design before we have tested everything. So here is the point where we know what we want to build, and this is the point where the design freeze should be. You all know that changes occur, changes in requirements or in feasibility. And so this is not a very suitable development process, and this is why we talk about SAFe today. So this was a quite nice handover to the SAFe chapter in here. And so I want to point out a little bit the myths which are out there, that you can't combine agile approaches with Automotive SPICE, or you can't combine them with functional safety, for example. And I would, on the next slides, I would like to point out that those standards like SAFe and like SPICE and models like SAFe are on working in different dimensions, and the points where we have conflicts between the two dimensions are only very few points to which we will come back later on in this talk. So if we look at the basis of SAFe or all scaling frameworks is Scrum, And as you might know, Scrum defines 3 accountabilities, 3 artifacts, 5 events, and it defines the rules of the game. So the current Scrum guide is only, I think, about 13 pages, a very small document, gives us some playing field and some rules, and how we work is up to us. So in principle, we don't have any conflict here. So all the engineering is up to us, and we could do functional safety and SPICE and whatever using Scrum. Another interesting point for those who work since several years with Scrum. So the last update of the Scrum guide in 2020 removed all technical terms like requirements, tests, and so on. So Scrum is now a very generic framework to solve problems in a complex environment. And this is also good for us, so we get more degrees of freedom in engineering. So this is about Scrum. Then SAFe defines similar things, but on a higher scale, with different layers, like the team or the art. You might notice it also defines roles, events, artifacts, the rules, and SAFe also is a quite large toolbox with different tools, which could be applied here. And the question is, what does SAFe say about systems engineering? Or for sure, it will not talk about SPICE, but what about systems engineering? And you might recognize this one. So this is the solution intent, and you could recognize the V model. And here we have specification, design, and test, and across this, the traceability. And what is very interesting and very useful for our further discussion today, SAFe splits the solution intent into the future and the current solution. So we also could say we have a kind of short-term documentation where we plan what to introduce in our system, and we have the long-term documentation, which says what is in our product currently. And we should have the traceability all across these things. And we will come back later on where we talk about the more practical things to the short-term and long-term documentation view. For the time being, or talking about agile approaches and systems engineering, I would also like to drop some words about documentation. This is always discussion. So years ago, when agile approaches were quite new to the automotive industry, I had a lot of discussions with functional safety guys, and I say, oh, in the Agile manifesto, there's written we don't need any documentation. And so we had a lot of, I said this 10 years ago, we had a lot of discussion of kind of misunderstanding of the Agile manifesto. So the first point is Agile approaches do not forbid to do any documentation. And where we also have discussion, especially with developers, development always means documentation. So development is not creating code. Development means managing complexity. And so creating code is only a small part, a very small part of managing complexity. Most of the work in development will be with models and documentation and so on. And to that we can cope with the small iterations and loops, we also should try to figure out how could we get our documentation lean or get a certain degree of automation there. So it's not only about test automation and build automation, it's also about how could we automate our documentation to go the next steps towards a real agile systems engineering. So we talked in these 2 chapters about, quick recap about Scrum and what does SAFe say about systems engineering, or what does SAFe define. And now we'll try to bring all this together. And we have 2 different layers and dimension here. But when we talk about the separation between what and how, we have to go a little bit deeper in here. So the first thing is on the product level. This is how Scrum or Agile approaches see this. We have the what level. This is what we have in the backlogs. What should the product do? And the teams define the how. It means the system design, the system architecture, and also the how of the work. So the teams also define how engineering is done in our team or in our team of teams. And when we go into this point of engineering, we have another what-how separation. For example, the team could decide, because we are in the automotive industry, we should develop compliant to Automotive SPICE. And then we go into this engineering level down here, and SPICE again defines the what in the engineering. So we have talked about the product up here. SPICE defines the what in the engineering, and we as developers have to define the how in the engineering. This means we have a lot of degrees of freedom how we could comply with the SPICE assessment model in here. So this is once again for discussion, the what and how level. We have this on the product and on the process side, and SPICE is also kind of framework what is expected and with some rules. But what we really do, SPICE is also not a process description or what we could use immediately. We have to find our way how to work, and that is compliant to the SPICE assessment model. So if we look in the SPICE assessment model, we encounter two main challenges. The first question is, what is a project? So this affects many three processes. And the second is what we have to define. What is the relationship between the backlogs we have in SAFe on the different levels, or out backlog, team backlogs, or even higher backlogs? And how does this relate to all the requirements we see in Automotive SPICE, especially those three processes I have depicted here. So if we want to work with SAFe and SPICE, these are the two main questions which have to be answered. There are other questions. So what about quality management and collaboration with suppliers, especially if we work in a real agile environment and not with a 10,000 requirement specification ahead. We can't collaborate with suppliers like we did before. This is more like a joint development and not throwing a specification over the wall and expecting some results years later on. So we will often change requirements, and also suppliers should collaborate in an agile way with us. This would have impact on the supplier monitoring from SPICE. So we are going lower and lower with the degree of difficulties when bringing those things together. And when we talk about the engineering, so the core engineering will stay the same, independent if we work in a traditional process approach or in SAFe or other agile approaches. This does not affect how we develop our products. So what could change is that we have different understanding of when is this work done and who does this work. But the engineering itself will stay the same, especially the architectural things, all the verifications in here. So this has been renamed to verification in the 4.0 PAM. And also those supporting processes who deal with problems and change requests. And last but not least, we also have SPICE. So I stick a little bit to the old VDA scope here. We have some processes which will not change, like software unit verification is quite independent of how we work. And also supporting processes like configuration management. We have to introduce configuration management somehow, or maybe even a configuration manager, even if we work with SAFe. So this is the overview. We have some larger topics to discuss, and some things which will not change. And so I would like to go a little bit more into the details now. The first question was, what is a project in SAFe? And you might notice planning onion here from SAFe. So we have planning horizons from daily to years, or many years in the portfolio roadmap, for example. And then we have to figure out what would fit to the definition of a project. And answering this question, already a Scrum sprint on iteration is if we do real Scrum, this is a complete project. So we have defined a scope, we have a certain commitment to achieve the sprint goal. We work there, we do all the tests, we do a review of the project results, so the sprint results, and we even have a lessons learned, what we call a retrospective. So this is very important. Scrum handles the complexity of our environment, not by being able to change at any time. So Scrum can change the direction between the sprints. So it's like a chain. You have rigid elements of the chain, and you have links in a chain where you can change the direction. So we try to deal with the complexity by doing very, very small projects, which we call Scrum Sprint. Regarding SPICE assessment model, this would be in our environment, in the automotive industry, in my opinion, a too small project to go into an assessment. So let's check what do we have more, and you can see this in the darker orange. We have the plans, and up here I have the roadmap. So a PI plan is a well-planned project. We have planned what would be in there. We have a detailed plan, iteration by iteration, what will happen in our PI. We even have done, by doing the confidence vote, we have done a feasibility check for this project, in quotes. So this would be a nice time frame or element in SAFe to go into an automotive SPICE assessment, for example. And indeed, we have customers where we assessed single PIs or PI plans, because there you have all the things, you know, from a project. We have very hard defined scope with which we go in there, and a very good and intense tracking. And for example, for companies who don't do customer related development, but have their own products and develop them from release to release. And if the release is also coupled to the PI plan, so we have done assessments here in these environments. When we talk about cars or ECUs, which are developed especially for one car project, we have to go to a longer scope. And here we have a certain challenge that the precise plan is only up to the PI plan, and up here we have what we call roadmaps. So roadmaps are the forecast. The roadmap's forecast, not a commitment. But this just reflects reality. We can't do a detailed plan until for the next 5 years, for example. And so when we talk about really car projects or supplier products like ECUs and so on, which go into a certain car project, we would do more a traditional assessment scope until start of production. And then we have to deal with the 2 levels of detail with this fixed plan here and this forecast here, but this also works. So it's even with a traditional project, it's not a realistic planning to keep the same level of detail across several years. So this would be the first step. If you go into SPICE assessment, you have to define what is our project. Is it the whole thing until start of production, or is it just something like a PI or several PIs, or is it a release? Maybe the release will not be aligned with the PI. Maybe the release is pulled out somewhere in there, and so you also could define the release as a project. That's the first question you would have to answer. Before you go into an assessment, this should be very clear what will be the scope in terms of what is our project which we will assess. So this was the first question in this major topic slide before. And a second, you might remember it, was how do we deal with backlogs and requirements. And when we look in the process assessment model, when we talk about requirements analysis, we have things like risk, effort, cost, feasibility. We have to analyze all these things. And we have also requirements in here like traceabilities and consistency and so on. And so this is all in the same, defined in the same process in SPICE, but we could split this in two different worlds, like the project management attributes and the product documentation. So for example, what was the implementation risk or the cost or effort? This is very important for the project management, but once the requirement is implemented and tested, we don't care about the risk and the cost. It's in there, and then we need to have it as a traced requirement for our long-term product documentation. So all these parts or attributes of the SPICE view on requirements will end up somewhere in Agile backlogs. This is the short-term documentation. So you remember solution intent, the future documentation. We want to have these requirements in our product, and it's used for the work management. And the long-term documentation, this is the things we have to keep 10 or 30 years or whatever. This tells us what is currently in our product, and there we have all the traceability and baselines and so on. And you might ask, okay, but if I have a real pure theoretical Scrum team which develops a web app or a web shop, for example, they don't, where is the product documentation here? Because normally in Scrum, you throw away all the stories and things after the sprint is completed or the story is implemented and done. Then you could just throw this away. This is a short-term documentation. But where have those pure software teams documented what is in my product? We could pick the stories out of the bin which we have thrown away, but there we would have the problem, maybe 17 different stories have changed one requirement over the last 3 years. And then it's very difficult to get a clear picture. So in the pure software environment, the long-term documentation could be the implementation of the automated tests. So the test automation in a pure software team would provide a long-term documentation. For us in the systems engineering, this is not enough, so we will work here with traditional requirements management tools. And this will also answer the question, will I be able to throw my DOORS or Polarion or Codebeamer or whatever away and work with Jira or other backlog tools in the future? Short answer, no. So we could use these two elements and see what we have here. So we have product backlog items or generic backlog items and save on different levels, and they have a certain life cycle. Like, this is a very simple one. It's created, it's ready. You remember definition of ready. Then somewhere it's planned into a sprint or an iteration or an PI. And at a certain point, it's done. And on the other hand, and this is normally the agile tool like Jira or whatever. And on the other hand, we have this long-term documentation. Our traced requirements, they tell us what's in here, and we need this for impact analysis if something happens in the field, or we get bug reports and so on, or safety issues. And here we could have other states in here, like in the traditional requirements, like created, analyzed, approved, tested, and so on. And often we have also a one-to-N relationship. So one backlog item, which is more like a stakeholder requirement, will be implemented by several system requirements. And this is why we also or often see the backlog items as the stakeholder requirements, which would be assessed with this one process, and here are the system requirements. And once you have those two life cycles, maybe you already have them in your two worlds, agile and systems engineering, you have to define how will you synchronize those two life cycles. So the most agile way would be this one. When I have planned the requirement or the story or whatever, so let's call it the backlog item. Once I have planned it into my sprint, then I will create all the things here. The blue world is created within the sprint. So this would be the agile way. I do all this dynamic replanning before we go into the sprint or into the PI when we talk about safe. And all these things are created in the sprint or in the PI by the developers. You could also define another relationship between the two life cycles. For example, you could insert into your definition of ready that for us, ready would mean that I have already a requirement created, or we could draw it to analyzed, for example. Ready would mean requirement is created and analyzed in DOORS, Polarion, Codebeamer, whatever. Or a very traditional approach, before I enter the sprint planning, I need to have an approved system requirement in my world here. It's not very agile anymore because it's very expensive to rearrange things and change things, but this could also be possible. So this will be your task. Define how you will synchronize those life cycles. And the very interesting point is where is the starting point in here. The easy one is this one down here. So done means done or tested or implemented or whatever. So this is the second major topic you have to care about. How do your backlog levels and save from the team backlogs, out backlogs, maybe solution, or the portfolio, how will this relate to your requirements in your requirements management tool? So those two things, what is the project? How do backlogs and requirements relate? Then yeah, turning to the finishing line, some more input about how will I get, if I am the SPICE guy in the company, how will I get all these evidences from my team? So if I have a Scrum team, there are two channels in here, one across the backlogs. There we could insert something like concept related artifacts like analysis, concepts, whatever. So if the team, in other words, if the team has to create a certain document one time, like requirements analysis or blah 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 feasibility report or whatever, we would put this in the backlog structure. And the second path into here is the definition of done, which cuts across all the things. And there we insert more the increment related evidences, like for every increment, I need a test coverage report. For every increment, I need a report from static code analysis. For every increment, I need this and that. So these are the two official channels. And if you have in your mind what is required or which documents are required from SPICE or to cope with the SPICE assessment, you have to think, is this more a backlog item that they have to create something, or is this an evidence which has to come with every increment we provide to the organization? A very important point on the last slide here, what we recognize that many companies have problems with swarming in Scrum teams. So swarming is a core concept of Scrum. What we often see is that people or developers in Scrum teams pick a story and develop the story through the iteration or through the sprint or through the PI on their own. And this means we have a lot of stories or backlog items in work in parallel. This gives us a very bad transparency. So we often see this, that 5 developers open 5 backlog items after the sprint planning, and they work 2 weeks in there. And at the end, on the last day, it's the quiz, which of them will be completed. So the idea is that we work down the sprint backlog in a sequential way. And the method here is swarming. This means we pick the first item from the sprint backlog and we assign as many team members to this item, what makes sense. So this could be 3 or 4 people working together collaboratively as a swarm on this backlog items. And maybe the other 3 or 4 people in the team will pick the second backlog item or second story in the sprint. But not with normal team sizes, with 5 to 10 people, it's not normal that we have more than 2 or 3 backlog items in parallel in progress. And this makes us very fast and we create very early output. So the swarm, they would align on the first story and say, okay, what is the requirement change? What is the architecture change? And maybe they spend one day with talking and then they go ahead and do all this in parallel. So one changes the requirements, one changes the code, one changes the architecture. And they keep all this documentation synchronized by working as a team on one table. And we have this completed after 3 days instead of waiting 2 weeks for this quiz, will it be done or not? And then we pick the next one. And this has nothing to do about SAFe and SPICE, but often we hear, oh no, we can't make a change with all the documentation within a 2-week iteration. This is too short time. And the answer is, yeah, go there as a swarm. And the very important point, utilization is not the highest priority. Output is the highest priority, not utilization. So maybe you know the problem with the curve of queuing theory. So according to the queuing theory, which applies to every factory and every development team, you have to decide if you want to have busy people or if you want to have results. And so, and it's a mathematical relationship. It's not something like religion or something. And as Scrum says, we prefer results instead of busy people. And this means go there with a swarm. Maybe one guy in your team will only be utilized by 30% for this backlog item, but that's okay. We have the result after 3 days. This is a last important thing beside all this engineering, how we get really fast and how we can also generate, this would be the link, generate all the necessary artifacts within a short period of 2 weeks. The solution would be swarming. So thank you for your attention. We're done with the presentation here and we could open the Q&A session now.